Okay, in question number 9, what do we have? 3 ohmic resistors are connected in series as shown in the circuit 1. Okay, the 3 ohmic resistors, they have been connected in series. Okay, then they are connected in parallel as shown in circuit 2. So in circuit 2 now they are connected in parallel. That's okay. So here they're connected in series, this one parallel. What should come into your mind? The resistance here is going to be definitely, because they are connected in series, the total resistance is going to be higher than what we have here. So here it's going to be higher than this. Yeah, the total resistance here will be higher than what we have in circuit 2. Remember, here you'll just add them directly, but here we will add the inverses, and then finally you get the inverse. And the resistivity of the entire thing in this parallel connection will be less than the least one. So let's see, which of the following graphs shows the relationship between the total potential difference. Okay, so we have some choices being given. So the choices they're talking about, let me just make it more straight. Now using these things, don't worry. In future, I'll be drawing very straight lines. Before we look at the choices, I want you to look at this one from what we are being asked. So they're saying, which of the following graphs shows the relation between the total potential difference between the total potential difference V and the current I in each circuit at a constant temperature. In each circuit at constant temperature. So the relationship between V and I, okay, V and I. The resistance here is high. Look at this one. How do you get resistance? We have the common one is always V is equals to IR. So the resistance is given by V over I. When the resistance is very high, what happens to the current? The current flowing will be very small. Yeah, higher resistance, the current flowing will be very small. So the first circuit, how should it look like? What about the second one? We should have a higher resistance here. So the current flowing should be low. The movement along the x-axis and y. So the movement along the x-axis should be smaller than what we have along the y-axis. But in this case, the resistance is very low, therefore the current flowing is very high. So you can even just think about it. And then there's something here that you need to know. They are ohmic resistors. So because they are ohmic, our lines should be straight. So I expect the one for circuit 1 to be very close to our y-axis compared to the one on circuit 2. Why? Because the current is supposed to be smaller compared to what we have for the voltage. So let's check their choices. So here, what do? The first thing, we will eliminate these ones. Here, this is not ohmic. So ohmic, we should have a straight line. Then from there, let's check. So if you look at what we have in this first one, this is circuit 2 and this is 1. So the steeper the line in this case, the higher the resistance. So in the first case here, circuit 2 is much steeper than circuit 1. So that's not true because the resistance of circuit 1 is supposed to be more than what we have for circuit 2. Yeah, for a larger flow in current, we should have a smaller. For a larger flow of the potential difference that is supplied, we should have a smaller flow of current. Oh. let me not over explain, I'll confuse everything. So here we will go with this one. So you just think of, if you take this point, so look at what we have for the current flowing for this given voltage. Then for that voltage, look at what we have for the current in this other one. For the second one, we have a higher current flowing compared to what we have in the first case for the same potential difference. So we go with this one. Yeah, here the current can be, maybe we can have 0.4, then this can be even 0.6 maybe. Yeah, so because the resistance of the first one is more, that is why the current flowing will be less. You can always eliminate others and then choose what you want. But the steeper the line in the VI graph, the more the resistance. Okay, then we have this one. A bulb rated at 2.5 watts and 3 volts is operated by 9 volts battery as shown in the opposite figure. Okay, so this bulb, you should take note of this one. The power of the bulb is 2.5 watts and the potential difference through it, let me just call it V, is 3 volts. So the first thing you are being asked is to state Ohm's law. So what does Ohm's law state? So Ohm's law, how does it go? Yeah, for a conductor at a constant temperature, you can try it out, a conductor at a constant temperature, let me write temp, the current in the conductor is is what? Can you read it out? Is proportional to the potential difference across it. Is proportional to the PD, potential difference. Yeah, so this part is equally important. At a constant temperature, the current in a conductor, for a conductor at a constant temperature, the current in the conductor is proportional to the potential difference across it. So here, this is a direct proportion. That is what we mean. If we say is proportional, then we just mean is directly proportional to. Okay. So the key parts at a constant temperature. Then we have current being proportional to the potential difference. Calculate the current through the bulb. Calculate the current through the bulb. So how do we get the current through the bulb? Look at what you have been given for the bulb. You have been given the power and the potential difference through the bulb. So we look for a formula that connects power and the potential difference and current, and it's always P is equals to what? V I. Good. What do we need? We need I. So I is equals to P over V. So our I is equals to P is 2.5 over V is what? 3. You can divide that one. 2.5 divided by 3. So what do we end up with? So this will give us a current of 0.83 amperes. Yeah, so the current I through the bulb is 0.83 amperes. That is the current through the bulb, okay? So still part C of the same number 10, so part C, find the value of R. Yes, we want the value of the resistor R. So how do we get the value of this resistor? How can you get the value of this resistor? So mostly we always use what? We have V equals to IR. Therefore, we always have R being equal to V over I. Do we have the current? Because this is a series connection, the current flowing through the bulb is the same current flowing through the resistor R. So we have the current. So current I is there. I is equals to, it was coming to 0.83 amperes. Do we have the voltage? No, we don't have the voltage. How do we get the voltage? Here we use what? We use Kirchhoff's second law. Yes, Kirchhoff's second law. What does it state? The sum of the electromotive forces in a closed circuit is equals to the sum of the what? Yeah, you can finish it up. If you're getting it right, you can clap for yourself. Yeah, the sum of the potential differences. So the voltage or the PD through R and this bulb should add up to this 9. So what do we mean? The voltage through R plus the voltage through the bulb, let me use B, should be equal to 9. Okay, it's like we have it. So the VR should be equal to, I can just move this because we have it, will be 9 minus the voltage through the bulb is 3. So the VR, the voltage through R, will be given by subtracting these two, and that will give us 6 volts. So we have the voltage through that resistor. You can easily get the resistance. Now R is equals to V. So our V is what? 6 we divide by our current, which is 0.83. Okay, please do that division. So what are you getting from that? Have you done that division? Well, you're just having some good time over there. So I'm getting R to be equal to 7.23 ohms. That is the resistance of this resistor. So it's very important to think of, for you to get the resistance here, you need the current and the voltage. The voltage through this resistor is not 9. Students will always make that mistake. Please take note that the voltage through this resistor and this bulb, if you add them, that is what should give you 9, because they are sharing what we have. So if the bulb is getting 3, then the resistor will get the remaining voltage, and that is 6. Yeah, the current is the same. Then from there you can get what you want. Okay, question number 11.